Yes, no, thank you. If you guys don't mind, first of all, thank you so much for joining us and for organizing this incredibly inspiring gathering with 20 countries. We are pleased to have this collaboration with you as Cambridge Forum, which is an independent forum that happens in Cambridge. If you don't mind, I'm going to share my screen. Um, so please bear with me for a second. Share. Can you see my screen?
Not full screen, but I can see a slide.
Okay, all right. So now can
Yeah.
you see the slide?
Yes, perfect. Now it's full screen. Thank you. Yep.
So I have it's a bit of a daunting task today. I have two daunting tasks. One, the subject is demystifying AI. And, usually I do this with almost a full day or half a day of work. So demystifying AI in 15 minutes is going to be quite daunting as a task. The second daunting task for me, this challenge is the diversity of the crowds in 20 countries. Some of you have advanced knowledge of AI, others don't. So if you do, please bear with me. Hopefully, for you, I will put my sociologist hat on. And for those who don't, I'll put my AI hat on to try and. The purpose is I would like you to walk out of today's 15-minute talk having learned something about artificial intelligence and stimulated to think more of it and to think of its possible implications, because that is what my primary concern. So we start today with a little bit of a game. I'd like a volunteer. And if I can ask you to play a song, and I'm going to demonstrate for you what I think of how I think of AI. So, Derek, could you play a song? Okay. Oh, so Red, Red Wine. That's an easy one there. So I have with me Shazam. Many of you, probably know this app. It was an app that was there way before the whole hype of AI. The issue is the mind-boggling thing for an average human being is how does Shazam do this? How does it? There's about 200 million songs in the world. How does Shazam know which song that was played here in a second or two? And for me, that's the essence of artificial intelligence, as an emblematic example of it. So why? Because Shazam doesn't know the songs. The machine doesn't know the songs. What the machine does is looks for a frequency. It converts the song into a frequency and it looks for a print within that frequency, almost like a stamp. And within a second or two, if it finds that frequency, it says, this is the song. And this is the essence of artificial intelligence because it's intelligence, it's able to know the song, but it's artificial because it actually doesn't know music, it's looking for a frequency. And I love this as an emblematic example. So that to me is the essence of what artificial intelligence is. Machines are able to process data in a way that we are completely unable to do as human beings. And they use this to automate or to answer questions or classify things. So that's the agenda for today. What is AI? Again, it's a daunting task to do it in the time allowed, but I'll do my best. What are the implications for us? I'll show you for the insurance industry. We use AI extensively in insurtech and so on. Now, basically, there's a delay. Okay, it's a bit of it. So artificial, I mean, there's a lot of hype now about AI and so on. So AI follows, there's, a larger umbrella of AI, which is artificial intelligence. And within that umbrella, there's machine learning, right? And within machine learning, there's deep learning. and then the latest iteration, which is generative AI. So AI is the general rubric for which these different processes follow through. And each of these processes, as you can see, has its own algorithms, its own processes, and so on, and its own purposes for how. So I thought a lot about AI during the course of my PhD, and I would say that the essence of what came up to me is three central processes. And I'm talking to an average person. If you understand these three central processes and think about them deeply, you'll understand the power of AI and you'll understand its possible implications. So the first process is classification. And that might seem like a simple process, not important. But classification is what makes it is the most powerful tool that we have as a human species. Let me repeat that. Classification is what distinguishes us as a species. Our capacity to describe the world around us and classify things is what makes us the strongest species on this planet. So, for instance, I started my chapter, I said a gorilla doesn't know it's a gorilla. We classified it as a gorilla, and we said it's part of the ape family, and we human beings, the gorilla could think of itself as Gugu or whatever. So classification is the most powerful tool that we have as human beings. Largely now we are giving that tool to machines to do things on our behalf. So think of what we're foregoing in terms of a power as a human species. The second important process, which is iteration. Iteration is, do you remember that game we used to play as kids? Hot, cold, hot, cold, hot, cold to find the treasure. The iterative processes of machines and machine learning is what makes them incredibly powerful. Because if a machine cannot get something in the first iteration and it improves through reinforcement learning, it will get it through the second or the third and fourth iteration. So the iterative process makes machine learning and AI an incredibly powerful tool, and it's one of its most important processes, this concept of reinforcement learning. The third is clusterization, the capacity for a machine to cluster things and find patterns in ways that we human beings are not able to find. So now the question is, why is AI important? And there's a million and one ways to think of why AI is important. But during the course of my PhD, I stumbled on two things that were mind-boggling. And we're talking, this is 2021, 4 years ago. This statistic by, IBM found that, 90% of all human data were created in 2016, 2017. This is a mind-boggling statistic, to think that it took human beings 5,000 years or whatever, I don't know how many years we have been recording data, and then just in 2 years, we created 90% more. So we are producing more data than we ever have been. And one of the speakers alluded to that. I mean, just think of just the mind-boggling data of YouTube, and you get an idea of this. The second thing that I found during the course of my PhD was Bill Gates said that the next breakthrough of machine learning is going to be 10x Microsoft valuations. And I used to think, this is before ChatGPT, I used to think, where, how could this be possible? And now with the emergence of ChatGPT, I don't see this as a problem. Now, there is now so much hype about AI, largely because of the emergence of generative AI and ChatGPT. But AI is not a new thing. I would venture to say we have increasingly become dominated by machines in a very latent way. And as sociologists, we're always interested in this concept of individual agency versus social structure. So one of the things I advanced in my thesis is that I suggested that actually the new social structures are not social and economic structures, they are machine-induced structures. So a machine right now decides who our friends are in social media. It recommends certain friends and so on. It decides what routes we take through Google and so on. It's making a decision on our behalf. And we are foregoing our capacity to make such decisions and giving it to a machine. An algorithm decides our credit score. Imagine how important your credit score is to your life. You cannot get a mortgage, you cannot get anything without a credit score. A machine is now deciding which book it recommends to us to read, when we buy something through Amazon. It's deciding on which, financial products. It's deciding on our careers. Not now, from 15, 18 years ago in Canada, machines actually look at the job applications in the government. No human being looks at them. So the people who know to put the key words that the machine is looking for would be able to get interviewed, while those who don't know these processes don't. So it's literally, and then there's the whole issue of security. Machines are flagging certain people as a security risk based on, a set of predictable, algorithms and so on. So I would venture to say that we are living in the age of the machine, and we have forgone our capacity to classify. Machines are increasingly ordering our universe. And we should be worried about that, I think, and we should think about its implications on policy and so on. Now, let's look at classification. What do we mean by classification? And I'm going to try to simplify it. As I said, for those who know AI, this might be rudimentary, but I'm trying to explain it in a way. So basically, how does a machine classify? And this is the essence of it. So let's say I want a machine to decide whether something is a bee or a wasp. That's the intelligence question. Bee or wasp? Can you decide as a machine? So how do I do that? I try to find data that could indicate bee or wasp. So we could look at the length of the wasp, the width of the wasp, right? And just build a support vector machine, an SVM, whereby if the length of the insect is a certain way and the width, it would be a wasp. If it's less, then it would be a bee. And then you would find the hyperplane. This is what people who do machine learning, part of the processes. Then you find the hyperplane, and the distance between this and the hyperplane suggests that it has a higher probability of being a wasp. So that's how machines classify. One way of, this is one algorithm called support vector machine. Suppose we're not able to find the hyperplane, like we see things in a circular way. So what do? Do we give up? No. There's one way of finding the hyperplane through three-dimensional data, and I'll wait for it to happen. So I'm unable to find the hyperplane here. So what do? Do we give up, or do we still try to find a way of finding a way of distinguishing this data? And this is how you could look at data in high-dimensional space. I want to stop here. So I'll give you an example how a machine could classify colors. Do you know the RGN colors, for instance? Red, green, and blue. So if you want to understand machine learning and artificial intelligence, you need to understand vectors. And vectors, so the machine converts things into vectors in high-dimensional space and tries to find the relationship between vectors. So if this was the plane for red, blue, and green, if it's closer to here, then it would be more red, more green. Do you see what I mean? So the space, the location of the vector gives you the embedded meaning in that space. And that's one of the central processes of classification. Now, I have a friend, he's an AI professor, applied mathematician, our chief scientist. He says, Ehab, AI is just a glorified linear regression. So as a statistician, you'll be skeptical about AI and AI processes. But, I want to show you this. And this illustrates why this is powerful. Has anybody seen this diagram before? Are there any mathematicians here, like really smart mathematicians? Can you give me the patterns in these numbers? Can you find any patterns in these numbers? Of course you can't. An average human being cannot find patterns in these numbers. So a statistician, in rebuttal to my colleague, might come in and say, oh, no, I know how to do the math of this. I'll know how to find the patterns. I'll try to find the minor statistical methods, I'll try to find the mean, the variance, and so on. Guess what? All four have almost the same exact mean, the same sample variance, the same correlation, the same everything. So you cannot find any pattern as a statistician between these numbers. But then what if we apply data visualization, using AI to apply data visualization? Then we will see entirely different patterns from these numbers that you'll not be able to see I'll just wait for you will not be able to see as a statistician. And that's the essence and the power of these tools, where they go beyond basic statistics, data visualization, the vectorization, the iteration, and the building of neural networks to find patterns and so on. That's what makes artificial intelligence so incredibly powerful. Now, recently, someone who's sort of called the godfather of AI, Geoffrey Hinton, was asked recently, and I find that extremely scary. He said, do you understand how neural networks work? Do we actually know how neural networks work? And he said, actually, we don't. And but I think I found a way, with all due respect and deference, to see potentially how we can visualize them, at least. Maybe we'll not know how they work, but we will see how neural networks, before I get to that, actually, so it's a bit, there's a bit of a delay. So, sorry for just saying that. Okay.
Yeah, if
Yes.
it's very interesting, but I wonder if we want to set up a separate dedicated session on
Yes.
the data analysis part. So, just as a little bit of exploration, for the audience, the idea of today's
Yes.
session is like an inspirational session, and if you want to connect with the speakers, please use the Connect with Speakers link that Shu will provide you in the comments.
Yes.
So the idea is that we have today's session as an inspirational,
Yeah.
let's say, first introduction, and then on a separate date, we can have a deep dive with Ehab, for example, about those topics. So just as an explanation for the audience.
Yes. So I'm going to conclude by showing you this video, because it's an illustrative video of how I'm going to show it to you guys here. Actually. So this is basically how a neural network functions and fires up. If I want to convert the question of converting numbers and having the machine trained to understand these numbers, so through various algorithms, like the perceptron algorithm, you're actually seeing how the neural network fires up in three-dimensional space. And Geoffrey Hinton says we don't understand how it works exactly. But if you're visualizing it, you're seeing how it's firing up, and you see how the machine is capable of replicating thought by understanding whether a number is 8 or 9. And I conclude with that. As I said, it's artificial intelligence, I think, presents one of the greatest revolutions of our time. Generative AI in particular. We are in Cambridge. There was a person by the name of Ludwig Wittgenstein almost 100 years ago who said that basically our language presents the boundaries of our world. So imagine now that large language models are going to be the boxes from which that limit basically our view of the world. So everything that we know is going to be within that box, but I would think that innovation would need to happen in what is the unknown unknown. And I'm inspired by this Douglas Cardinal, the great Canadian native architect, who said, who had a shaman told him, all of what we know, all of what we know that we don't know is in the little hands of God. But he said, uh, where you need to go to innovate is in the unknown unknowns, and that's where the eagles roam. So I want you to think about how AI might be limiting our capacity to go to where the eagles roam. And with that, I conclude my talk.